An important note to make concerns some properties of series. So if you assume that the sum n equals 1 to infinity of a sub n converges and the sum n equals 1 to infinity of b sub n converge, then what do you think is true about the sum, number one, from n equals 1 to infinity of some constant c times an? What do you think you can do with that c? What have you always been able to do with the constants, whether you were dealing with integrals or something? Pull it out front. Now, it's actually not a trivial thing to say this is true and to prove it, but it at least seems intuitively true. It's really an extension of the distributive law, isn't it? Because if you write out that sum longhand, it's on the right side, it's c times a1 plus a2 plus a3 plus a4 plus dot, dot, dot. On the left-hand side, it's the c distributed, c times a1 plus c times a2 plus c times a3. It's an extension of the distributive law. So that's an important property. And it works if the sum of a and converges. If it doesn't, it's complete nonsense to pull out the c. Okay, and then how do you think the sum of the sum or difference of an, how do you think you could rewrite that? Yeah. Make it the sum from n equals 1 to infinity of an, and then separately plus or minus, it works for minus 2, sum n equals 1 to infinity of b sub n. And the warning, careful when using 2. Both individual series must converge for 2 to be true. And I'll leave you with an example showing why that warning is important. So we have, in this example, we have our sum n equals 1 to infinity of negative 1 to the n. Does that thing converge to anything? Now, if you look at the partial sums, S1 would just be negative 1, right? S2 would be negative 1 plus 1, which would be 0. S3 would be negative 1 plus 1 minus 1, which would be back to negative 1. So it looks like to me this alternates, the sum at Sn alternates between, depending on the n, between negative 1 and 0. So it doesn't converge. The series doesn't converge. Does that make sense to you? What about this second sum, the sum from n equals 1 to infinity of negative 1? I changed the exponent to the n plus 1. And if you write it out, it's 1 minus 1 plus 1. Does that then converge? No. What does it alternate between? Positive 1 and 0. S1 would be 1. S2 would be 1 minus 1, which is 0. S3 would be 1 minus 1 plus 1. Back to 1 again. So this one alternates. This one alternates between 1 and 0. Does not converge. What happens if you combine two non-convergent series in this case? What happens if you take the sum, so this would be like the an right here. This would be like the bn right here. What happens if you take the sum n equals 1 to infinity of negative 1 to the n plus negative 1 to the n plus 1? What is Sn going to be for all n? Since you have an even exponent and an odd exponent and 1, depending on what n is, one of the exponents will be even, one will be odd. Which means you're going to have a negative 1 plus 1, one way or another, in any particular term of the series, right? So this is 0 for all the terms. So what does it converge to? What's the sum of a bunch of zeros? 0. The point here is you couldn't split this up going the other way, could you? You couldn't say, since this series converges to 0, the individual series in pink converge. Or is that purple, lavender? I don't know. Good thing I'm not an interior designer. So in order for this property, this is an example of why this second property, in order for this to be true, that both individual series must converge.